Previously on the advent of cyber. After it was discovered that Best Festival Company was now on the blockchain and attempting to mint their own cryptocurrency, they were quickly compromised. It is now up to you as a red team operator to discover how the attacker exploited their contract and attempt to recreate the attack against the same contract. So the first thing we need to do is we need to look on the left hand side and hover over these buttons here until you find the one that says load local file into the current workspace. Then we're going to choose the 08.10 commit, and it's compiling attack sol. So now we're going to repeat the process, but we need to switch to a different account because we're now going to attack it with the attack smart contract. Okay, so now we want to deploy the attack sol smart contract. Just take the account ether store and paste that into the deploy contract and then click deploy. 1 ether in there and try to start an attack. Well, would you look at that? I think something happened. We have been given a flag. Hello world and welcome to Hacks. We are back looking at day 9 of the advent of cyber. Pivoting, dark the halls with loads of payloads, la 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 la, la 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 la. So, pivoting. What is pivoting? Pivoting is a technique whereby you use one computer to attack another computer. So you could have one computer with multiple interfaces on it, but you only are able to access one interface. Once you've compromised that host, you're then able to take the other interfaces and add them as routes to your attack box, which should then allow you to attack the other networks that are connected to the other interfaces. This task is going to require us to deploy a Kali Linux virtual machine and attack a web server running a web application. Once we've compromised a server running a web application, we're able to discover that it's running inside a Docker container. From there, we're able to auto-route to get access to a database and dump some credentials. From there, we can use proxy chains to connect to SSH with the credentials that we've dumped from the database. The story. Because of the recent incident, Santa has asked his team to set up a new web application that runs on Docker. It is supposed to be much more secure than the previous one, but better safe than sorry, right? It is up to you, Muckskiddy, to show Santa that there may be hidden weaknesses before the bad guys find them. So the first thing you want to do is you want to come up to the top, and where you have your attack box, you now have a drop down menu. You want to select Kali Linux and then click it so it spawns. Then you want to come down to the labs and click start the machine. Wait for those to start, and then once they're up, you'll have the IP address that you need to attack. And then you can show split view, and then you can full screen it in another tab. Now we want to fire up a terminal, zoom in a little bit, and we want to kick off an nmap scan against the target. So it's 10.10.182.172. So we're just going to grab that, we're going to paste it into our trusty THM clipboard. Fantastic. And then we're going to do nmap, we're just going to paste the IP address in. And then we're going to see what ports are open. I think that's all we need to do for now, to be honest. We can get more advanced later. So we can see right away that we have a web server and nothing much else. If we did a service version, we probably could have known that it was running on an Apache Ubuntu box. But at least now we know that there's a web server on the box. So let's head over to the IP address and see what we got. http:/// pop in the IP address, and we have a generic website. Not much going on, some Latin boilerplate text, but we look down here and they've given us some version information. We can see that it's using PHP version 7.4, but it's also using Laravel. So what we can do with that is we can head to our terminal, and then we can bring up a new terminal and increase the size, and then do MSF console. Then after a short delay, Metasploit should have loaded, and then we can do a search for Laravel. I'm just going to grab that so I don't spell it incorrectly. Head back to our terminal and search Laravel. And we should see we have a number of different vulnerabilities. We have a Laravel token unserialization and a remote code execution. If we head into number 1, have a look at the options, we can set our host. Let's check our ifconfig first of all. Our IP address is on eth0, so we want to grab that. Our local host to that IP address, so the reverse shell will come back to us. And then we check the options again. Then we see we need to set a remote host, which is going to be the target of the box. So we want to set our host, and then we can run check against it to see if it's vulnerable. Checking component version, the target appears to be vulnerable, so then we can just do exploit. and see what happens. Fantastic. So it looks like we have a command shell that's come back to us. Then from this command shell, we should be able to run commands like who am I, and we can see that with www.data, which is the web server. We could run ID, we could run groups, www.data again. This is a good first step, but we can upgrade this shell to a Meterpreter shell, which will give us a lot more features and functionality, which should help us in our exploitation. So what I'm going to do is I'm going to type background to send this session to the background, and then all I'm going to do is I'm going to do sessions -u for upgrade -1 for the last session, and you can see now that it's started a reverse handler, and we should get a Meterpreter session back to us, and that should allow us to sessions-l, and you can now see we have our initial shell and now a Meterpreter shell. Then from Metasploit we can do sessions-i to interact with the session, and we want to choose session 2, which should drop us into Meterpreter, and then if we type help, you can see we have a lot of different options that we can now use to get information about the system. So for instance, there's one there, sysinfo. Let's run that and see what happens. Sysinfo, and you can see there we're running on a Debian box x86 processor, but we can do other things as well. We can look at the list of running processes, and this is quite interesting. This does not look like a traditional list of processes. I would expect to see much more on here if we were dealing with an ordinary system. So I accidentally killed my Meterpreter session, but what we can do now is we can cat var environment, cat out the environmental variables, and you can see we have some database connection details. Port 5432, Postgres for the database name, username and password, but the host is web server _ database. But unfortunately, if we grab that and we drop into a shell, we can see that things like ping are not enabled. Ping, the binary, isn't on the system, which is typical in environments like Docker. You would remove all the binaries that a threat actor could potentially use to get out of the system or perform nefarious actions, and it just makes sense because you don't need it on there. If you're running a web application inside a Docker container, why does that Docker container need ping? So we're just going to background the session again. And there's this neat little trick that we can do where we can use Meterpreter to resolve that address. And it will give us the IP address of 172.28.101.51. Grab that, pop it in your notes because we're going to need it in a moment. Now, if we background our Meterpreter session and not kill it like I did a moment ago, we can grab the IP address. And we know this isn't going to work because it's an internal IP address and we're not on the same network as it. But if we just try and ping it anyway, just for the sake of demonstration, you can see there's no route to host. It's going to time out. It doesn't work. And we know it's not going to work because this IP address is accessible via the Docker container's other interfaces. So it will have more than one interface configured, and one interface will lead to the database, and one interface gives us the publicly accessible web address or the web application. So in order to be able to access that database IP address, we need to tell Metasploit that we have to route it through the host that we've already compromised. So we have our sessions-l already active. So we have a session there which is connecting to the web application, and we want to route traffic through session 2 to that host. And the way we're going to do that is we're going to do route add, and then we're going to do the IP address of the database, which is 172.28.101.51, and then we're going to use the CEDA address of 32 because it's a singular IP address, and then we're going to say session 2, and then it will say route added. Then what we can do is we can do route print, and now you can see that all traffic can go through session 2 to the database server. And one more thing I wanted to check before we go forward is for the presence of the Docker file, because we do suspect we're on a Docker container. So if we do sessions-i2, then we drop to shell, and then we do ls-lash on root, you should see that there's this Docker environmental file. What is likely set up here is that the Docker host itself is going to be configured with the IP address 172.17.0.1. So the individual containers will have their own IP addresses like the database of 172.28.101.48, but the actual host itself is probably on .1. So we're going to add another route for 172.17.0.1 via session 2, and then we can see route print, and we now have both routes added through session 2. So let's get back on track. Let's talk about the database. We know the database name is Postgres, we know the username is Postgres, and we know the password is Postgres. We also know that it resides on this IP address here, which is only accessible via session 2. So what we're going to do is we are going to search for Postgres, and we're going to look for a module called schema dump. So that's module 16, so we're just going to use 16. Then we're going to have a look at the options, and then you should see database Postgres, display results true, password Postgres, username Postgres, and all we should need to set is the R host. So if we come back up to our roots, we can just grab the IP address and then do set R hosts and then paste the IP. Check the options just to make sure that it's set correctly. And then we're going to run exploit, and you can see that we now have a dump of the database, and it shows us that we have a table for users, which contains usernames and passwords. So what we can do with that is we can use a different module to hopefully dump the contents of the database, specifically the users table, so we can get the username and passwords, and maybe that will contain some information that we could potentially use to access sensitive areas of the host or reuse later. So we're going to do another search for Postgres, and what we should see is Postgres SQL, which is number 11. So I'm just going to use 11, and I'm going to check the options, and you can see there that we have a database which we need to change. So we're going to do set database to Postgres. Just check that's been set. Fantastic. Now the password is correct, the username is correct, but we want to change the SQL parameter because we could run it now. If we run it now, it should give us the version of the exploit, provided we set the remote host first. That would be, let's grab that from there and paste that in, and then we can try running exploit again, and then we should get the Postgres version back. But what we want to do is we want to change that SQL parameter to our own sort of query. So we're just going to do set SQL to select all, and a wildcard or an asterisk means all, from users. Okay, that's looking good now. So remember, we're not actually attacking the database directly. We're having to use the roots that we added through the web application that we compromised, that we have running in session 2, to now run these commands. So if I do exploit on this, it worked first time. You can see that we now have the contents of the users table, where the username is Santa and the password is $. So copy that into your clipboard and make a note of it for later, because we don't want to lose that. We now need to set up a SOCKS proxy, and what this will allow us to do is it will allow us to set up a port which forwards all of our normal tool traffic through our local host, through our local port, into that sort of network via the routes, so that we can scan that 172.17.0.1 address, the host where the Docker containers are being hosted. So in order to do that, we're just going to do search SOCKS, and you should see number 0, we have SOCKS proxy. So I'm just going to use 0, and then I'm just going to use the syntax that they've used on this because it seems far easier. I've never realized you could do this with Metasploit before, but we're just going to do run server host equals 127.0.0.1 because that's our host, and then server port equals 9050, and then we're going to specify the version 4a. Now that's running in the background. So now if we open a new terminal, what we should be able to do is run a curl via our proxy to the 172.17.0.1 address and get some data back. So let's try that. We're going to do curl _proxy SOCKS 4a : / localhost, and then the port we specified of 9050. And then we're going to do http / 172.17.0.1 -v, and hopefully this should return some information. Brilliant. So we now know that our proxy is working and it's getting through to those hosts that we weren't able to connect to earlier. So what we can do with this further is we can leverage this with a tool called proxy chains to proxy mmap traffic through to that host, because we're scanning our own host, which is then forwarding the scan request onto the next host. I'm doing a terrible job of explaining it. I haven't used proxy chains all that much, but it should go a little something like this. Proxy chains -q mmap -n for no DNS, I believe, -st for a TCP scan, -pn for no ping, because ICMP doesn't work well with proxy chains apparently. Then we want to specify our ports of 2280.443, and they've also got 5432, and then we're going to specify the address that we cannot reach normally, 172.17.0.1. Fingers crossed. Whoa. And it's already come back with the results. If you ask me, we are bordering on black magic and witchcraft at this point. I'm not sure how proxy change automatically recognized the proxy that we had set up. I don't know. I'll have to do some more research into it after the video, but we know 22's open and we have credentials. Let's go and see if it works. Gonna head back into Metasploit, and then we're gonna do search SSH, and then we're gonna try and refine that search a little bit more by doing search SSH_login instead. Then we're gonna use 0, then we're gonna look at the options, then we're gonna set our host to 172.17.0.1. Then we're going to set the password to our password that we found earlier of lowercase p for dollar bill, W, and I think that's a 0, and then RD. Then we're going to set username to Santa. Then we're going to check our options. So we have the password, we have the remote host, we have the username. I think that's all we need to do. And then we're going to exploit. Then we can do sessions -L. And then if we do, we're root on that. So if we do session, can't type, getting excited, -I3, who am I? ls-lash. And then we can cat the root.txt file, grab that, and that is the box done, finally. So we can just pop that in, and then we'll go through and answer the other questions now. So deploy the attached VM, wait a few minutes, what ports are open? Was it just port 80? What framework was the web application developed with? That was Laravel, Laravel. What CV is the application vulnerable to? Oh, geez. Okay, let's get rid of that. And let's exit out because we no longer need to have access to that box. Let's do search Laravel and then do info on 1, and then we should be able to grab that CVE number, copy that, pop that into the clipboard, grab that out, paste that into the answers. So we're going to paste that, submit that. What command can be used to upgrade the last open session to an interpreter session? So I think it was sessions-u-1 because it was the first session and we wanted to upgrade it. What file indicates a session has been opened within a Docker container? So it was /dockeremv, maybe? Yeah, brilliant. What file often contains useful credentials for web applications? The .environmental file? That was where we find the Postgres stuff. What database table contains user credentials? That was just user or users. Fantastic. And what was Santa's password? Well, we know that was what ports were open on the host machine. So it was... Are they going to be funny about which order I paste them in? Go away. Let's have a look. 2280. Okay. There was more than that. Submit. 22 and 80. Okay, that's done. Day 9 is done. You might want to take a while to deserve rest. No, yeah, you're telling me. If this challenge was right up your alley, go through the compromising Active Directory module, which I can't wait to do. Complete. Oh, I'll tell you what, that's a relief to get that one out of the way. I had so many issues with the box shutting itself off, and then I accidentally closed my MSF console terminal, so everything reset itself again. But it was a lot of fun. I really enjoyed this one. Anyway, this has been going on for a long time. I now need to edit it. Hope you enjoyed it. I hope it helped you get through it. There's a lot I need to learn from it, especially with proxy chains. But that's all I got for you today. Kind regards.